Hi folks, this is Checkpoint Quiz 8.5. We're given a system of linear equations and we're asked to find y using Cramer's rule. So Cramer's rule involves using determinants. And to find y using Cramer's rule, we need to find the determinant dy and divide that by the determinant d, assuming of course the determinant d is not 0. So what is the determinant d? That's the determinant of the coefficient matrix. So that's the matrix where each column represents the coefficients of the variables in each of the equations. So the first row of the coefficient matrix corresponds to the first row of the coefficients here in the first equation. So I have 3x's, 1y, negative 1z's. The second row I have 2x's, minus 4y's, minus 5z's, and the third row I have 1x, minus 1y, minus 1z. So how do I go about expanding this determinant? Well, I'm going to expand this by the first row. And if I expand by the first row, I have to get the signs correct. So I've got a plus 1, minus 1, plus 1. And so when I go to expand the determinant, I have the plus 1 times the first entry here, which is 3, times the determinant of the 2 by 2 matrix I get by ignoring the row and column the 3 is in. So that would be this little guy here. Then I add to that a negative 1 times 1 times the determinant of the 2 by 2 matrix I get by ignoring the row and column this is in, 2, negative 5, 1, negative 1. Last but not least, I add to this sum the positive 1 times negative 1 times the determinant, wipe out the row and column that's in, 2, negative 4, 1, negative 1. And now I said about simplifying. I have a positive 1 times 3. That's just going to be 3 times. Take the determinant of the 2 by 2 matrix. I multiply these together. I get negative 4 times negative 1, which is a positive 4. And from that I subtract the negative 5 times negative 1, which is a positive 5. Now I'm adding a negative 1 times a 1, so that's going to actually be a subtraction of this determinant. I take 2 times negative 1, and that gives me negative 2, minus negative 5 times 1, negative 5. I have a positive 1 times a negative 1, so that's going to be another minus. This determinant, 2 times negative 1, is negative 2, minus negative 4 times 1, negative 4. So I work this out. 4 minus 5 is negative 1, times 3 is negative 3. Negative 2 minus a negative 5 would be negative 2 plus 5. That would be a positive 3, but I'm subtracting it, so I subtract that off. Negative 2 minus a negative 4 would be negative 2 plus 4. That would be a positive 2, but once again I'm subtracting it. And so when the dust settles, I get negative 8. What's important about negative 8? It's not 0. And since the determinant of the coefficient matrix is not 0, that means we have a consistent independent system, which means there's going to be only one value we get for y. Now we need to find the determinant dy. To get the determinant dy, what we do is we replace the y column with the constants. So instead of having 3, 1, negative 1, we have 3, 9, negative 1. So sometimes it's helpful to fill these in by columns so we don't get confused. The x column would be 3, 2, negative 1. So just the coefficients of x on down the line. Now I feed in the constants where the y goes, and then the z's. And now I expand this the exact same way I expanded the other determinant. So we'll go ahead and expand along the first row. So plus 1, minus 1, plus 1. So this is equal to the plus 1 times the element 3 times the determinant of the little matrix I get by ignoring the first row and first column. So that's 4, negative 5, 3, negative 1. Now I add to this the negative 1 times 9. Oops. Try to be consistent here. Negative 1 times the element 9 times the determinant of the 2 by 2 matrix I get by deleting this row and column, 2, negative 5, 1, negative 1. And then I add to that a positive 1 times a negative 1. Oops. Try to line this up a little better, be a little neater here for you. That should be at the negative 1 there. Times the determinant of the 2 by 2 matrix I get removing the row and column here, 2, 4, 1, 3. All right. A 3 times positive 1 is a 3. Now I take the determinant of this 2 by 2 matrix. I take 4 times negative 1, which is a negative 4, and subtract from that the negative 5 times 3, which is a negative 15. I'm going to add to that a negative 9, so it's really subtracting 9 times this determinant. I take 2 times negative 1, that gives me negative 2, and I subtract from that the negative 5 times 1, which is a negative 5. Then I'm adding 1 times negative 1, so that's going to be another subtraction. 2 times 3, which in this case is 6, minus 4 times 1, which is 4. So let's work this out. Negative 4 minus negative 15 is really negative 4 plus 15. Negative 4 plus 15 is 11, times 3 is 33. Negative 2 minus negative 5 is really negative 2 plus 5. That's a positive 3 times negative 9 is minus 27. Minus 6 minus 4 is 2. Alright, so when I figured this out, I get 33 minus 27, which is 6 minus 2 is 4. So y is dy over d. The dy we found to be 4. The d was negative 8. So that tells me that in this consistent independent system, the value of y is negative 1/2. So that'll do it for Checkpoint Quiz 8.5.